Welcome to the installation and usage guides for the Sparklabs Wolf engine. Here at Perfect Airsoft, I've been a fan of this engine for a long time, so I'm happy to finally make a video to pass on this knowledge. This video is going to be more dry than the others and quite information dense, so I recommend also using the chapters for future revisits. Let's jump right into it. In the box you get one engine, one programming unit. It does not need to be connected for normal function. It's only if you want to make any changes to the FCU. One FCU with various cables. A cable to connect the programming unit to the FCU. A nozzle adjuster to adjust the length of the nozzle. A spring guide replacement. This is only for normal gearboxes. QD gearboxes need a different approach. And a bag containing electrical isolation shims, magnets, and stickers for the selector plate. You also get a 6mm air hose that you can cut to length later on. Since this is an upgrade part and not a complete gun or drop-in gearbox, you'll also need a few extra parts. You need a regulator and an air setup. Anywhere between 50 to 150 psi is fine. Typical pressure you use with the Wolf engine is around 100 to 120 psi. You need a battery that fits the JST connection, or you can simply solder on your own connector to the FDU to use normal LiPo batteries. You need some glue for the trigger magnets, a few shims for the trigger, in my opinion, not strictly necessary but nice to have, and whatever tools you need to disassemble your M4AG and gearbox. First we install the air hose. This is a bit tricky as it's very tight to get onto the engine. I found that just heating it up gently for 10 to 20 seconds is enough to help guide it on. Make sure you don't melt it though, it should only be just slightly softer than normal. Now it's been installed, but we don't need to cut it yet. We do that later on as needed. Take your AG and disassemble it. Open the gearbox and remove all the parts. Of the original gearbox parts, you'll want to reuse the following: selector plate, safety blocker if your gun had one, and if your gun has a QD system, you also need to use the original spring guide. Bearings you can leave in, that's up to you. Also, make sure that the gearbox is clean of any grease and debris or whatever. And when you've done that, you're ready to start the install. First, we must check that the ETU fits unimpeded in the gearbox. Many times there can be a raised section around the pinholes or the sector gear, and especially down here on the G&G and Crytek models, but that can be easily remedied with a Dremel. Take the ETU, put it in, don't force it in, and it should be able to fit flat in the gearbox and not tilt up or down or hit this corner here. Reuse your original screw with one of the nylon washers pushed on. Like so, don't over tighten it, it should just be enough. After that, just double check that the screw does not protrude on the back side of the gearbox. If it does protrude, you need to grind it down slightly. Then you route the battery wire. Now luckily we don't have a motor to guide it under, but we should still make sure it sits nice and tight. After that, you can install the programming cable. The programming cable has two connectors. One is a micro USB connector and the other is a connector for the board itself. It just needs a soft push and then it clicks in. The programming cable is not strictly necessary to operate the gun, but it makes sense to have it permanently wired in for ease of access to programming later. Selector install. Take the selector and clean up this area here. If you have a metal clip around the selector, as some older guns do, I suggest removing that as well. Take a sticker from the included sticker pack and install it in the same way I have done here. These stickers are designed with a light to dark gradient. This is to change the amount of light reflected to the sensor on the back side here of the ETU, based on the position of the selector plate. You get 4 of the original ones, but you can also make your own if you have some weird proprietary selector plate or just want to toy around with it. Slide the selector plate in. Next up is the trigger install. Now the manufacturer has included a special magnet holder that you are supposed to glue on to the trigger here, But personally, I prefer just gluing one of the normal magnets also included straight to the trigger as shown here. But either way should work really. Again, make sure the trigger is clean of any oil. You can use any type of glue for this. I prefer a Loctite quick drying soft glue. You just use a little drop, not too much. Then put the magnet on and adjust it into position. The polarity of the magnet does not matter. For this, you want to use a tool that is not made of metal, so you don't accidentally pull the magnet out while it's still drying. Avoid getting any glue on top of the magnet if you can. After letting the glue dry, we can now check trigger clearance. Put the trigger in and check the following. 1. Does it actually hit the sensor when you move it all the way forward? It shouldn't. You should also want to check that it does not hit any of the board components. This is a bit difficult when the top shell is not on, so you'll want to put this top shell on and maybe have a look down the cylinder window here and see if it can wiggle into any of the components when you move it, but it's usually not an issue. Additionally, you can put some shims on top of the trigger right here to take out any of the slack in the system. It's not strictly necessary, but it's something I like to do, especially when sensors are involved. Like so. You have to figure out yourself how many shims you need to use. For the rear spring guide, you can use the included replacement part. However, this is only for normal gearboxes and won't work with QD design gearboxes that still uses a spring guide with a screw-in to hold the stock. For those kind of situations, you'll want to use your original spring guide, but disassemble it with tools, so you just have the remaining part here that you can then use as a little adapter. The reason for this is if you have the engine in, there is not room for a full-size spring guide. To install the engine, first connect the two board connectors. The wires from the front of the board goes to the front of the engine, and the wires from the rear of the board goes to the rear of the engine. So you take the first one, which is a bit tricky, and give it a push until it gives a click. There. You take the rear one, and this one is easier to click in. If you have to remove these connectors, don't pull on the wires, make sure to pull on the plug itself. Now we're ready to assemble it and put all the parts in. So you guide the engine in place here, make sure to not pinch any wires. Then gently put the top shell back on. When you do this, you'll want to check that the wires are not getting pinched at the back. That's very common. Then put the screws in and whatever other parts your gearbox needs. After you put the screws in, you give the engine a little bit of a tug and a wiggle to make sure that it's not actually loose in the gearbox shell. This is important to prevent any accuracy issues down the line. If you do have a loose engine, it's quite simple to fix. A single strip of aluminium tape wrapped around the front or one area of the engine will allow it to clamp better on the engine, and that'll usually solve it. Assemble it into the rest of the lower and with the stock tube. When you're putting the pins back into the receiver, just have a quick look through the holes here and make sure that there's no wires blocking either. If there is, you can take a little screwdriver and see if you can wiggle them to the side, or you have to disassemble and figure it out. Now we're ready to adjust the nozzle length. Pull the nozzle out so it's in the front position. Take your hop-up chamber and push it against the gearbox. You should feel a very slight pushback at the end. If you don't feel this or think the nozzle is adjusted too far out, you can easily adjust it with the included tool. Simply insert the tool and turn it clockwise to adjust the nozzle in or counterclockwise to adjust the nozzle out. In this case, we can see that it starts to already touch on the bucking lips right here. It's about 1 millimeter, 1.5 millimeter, and that's too much. So I'm going to adjust this in one turn. there's still about 0.7 of a mil of play. That's too much. It should be so it's only just pushing the hopper back out like 0.1, 0.2 mil. And give it a bit more in here. So now it's almost there. Just give it a tiny squeeze further in. There, that's perfect. Please note that although you can adjust the nozzle length, it's only meant to be adjusted a little bit. It's meant for normal M4 chambers, and it can adjust about 1-2 mil each way. So now we're ready to turn on the rifle. The first time you turn it on, the programming unit will run a calibration test of the trigger and selector. If you skip this step or miss this test calibration for whatever reason, don't worry, I'll explain later how to redo it manually. First, connect the programming unit to the programming cable. Then connect the battery. I'm just using a normal 7.4 volt LiPo here. You'll hear a beep and the menu will immediately go to self-calibration the first time you turn it on. I'll show this now. First, it asks you to confirm that there are 3 selector positions. This is correct for an M4. 1, 2, 3. Press the menu button to accept this. Now we're calibrating those selector positions. So first move the selector to safe and press the up button. Move it to semi and press the up button. Move it to full auto and press the up button. Done. Now we have to calibrate the trigger. You press it full in and full out a couple of times and that should do it. And now we're done with the calibration. At this point, you can adjust the engine further, but out of the box, it already has pretty decent settings that you can play with. If you're having issues with getting the selector or trigger to calibrate correctly during this process, please see later in my video where I explain how to troubleshoot this in detail. To test fire the gun, first set the pressure on the regulator to about 100 psi. Connect the regulator, and then listen for any air leaks in the system. Don't chrono your rifle yet. If you don't have the opportunity to shoot and sight in your rifle at home before chronoing it, at least dial the hop up a little bit so it holds the BB. Now to adjust the velocity of the gun, you have 4 ways to do this that you need to combine together. First you have the regulator pressure that you can adjust on your regulator, typically between 50, 80 to 150 psi depending on your regulator. The engine itself will take 0 to 200 psi. And you'll generally want to set that between 90 to 120 psi in my experience of using the Wolf engine. The process I would use is that barrel length and BB weight are already set. They're based on your gun and what BB weight you want to shoot, not for energy, but for distance and accuracy. Then I'll set the valve dwell to around 0.50 as a starting point. And then I set the regulator pressure and I go from there. But if for some reason I need more and the regulator can't really give that to me, then I start to increase this up to 1 or 1.5 or 2 milliseconds even. Just know that this is less efficient. It's always more efficient to run a higher pressure with a low volume. Here you have the valve dwell setting. It's on the first row of menus, quite easy to access. Out of box, it comes set at 1.00 milliseconds. That's fine. I like to run mine around 30 to 50. I would not recommend to run it at 0, though it is possible, because there could be some stability things. You're running really low volume then. It's pretty simple to adjust the valve dwell. You just adjust it up and down with up and down buttons. And you can do this when you are at the chrono or wherever. I would say you can adjust it about 20, 30 FPS plus minus, depending on your gun setup. Right after installing and making your gun ready, there might be some additional things you want to change. The official documentation has a good explanation of all the functions and I've linked it below. In the future, I'll also make a video that explains the menu system in detail, so subscribe to see more of that. The Wolf engine has a ton of settings, so I'll give a quick rundown of the most popular ones. First is the fire modes. Repeatedly press the menu button until you get to fire mode. Here. As you can see, the programming unit changes depending on the position of the selector. So change the selector to the position you want to change fire mode on, in this case, the full auto position. Here you can see that it says full auto already. To change it to semi-only, simply use the up-down buttons to adjust it. And now it's in semi-only. All the selector positions can be programmed this way independently, and yes, there is a binary setting. To adjust the rate of fire, simply use the up-down buttons to adjust it up and down once you are on it. However, the system will automatically be limited by the valve dwell and the BB dwell. In this case, that's 26 RPS. So to reach really high rates of fire, you need to do further fine-tuning on those parameters first. The Wolf engine can also switch between open bolt and closed bolt in software. To do this, you have to navigate to the second row of options by holding down the menu button like so. There. Now we're in the second row of menus. Then cycle through the options again with the menu button. On Nozzle mode, you can use the up and down buttons to switch between open and closed bolt. Now the engine is in closed bolt mode. You can see that after every shot it remains forward. And now we switch it back to the open bolt mode. And you can see that it remains back now after every shot. Now, in my experience, I found no difference in accuracy between closed and open bolt, so I recommend just using open bolt. To get back to the normal menu system, hold down the menu button again until it switches back. There. BB dwell sets how long time the nozzle should remain forward after the air valve closes. You can adjust this down until you start getting FPS inconsistency and then back it off a little. Generally, this setting should be between 2 to 5 milliseconds. This is the nozzle dwell setting. This one is critical for performance. Increasing time on this gives you more time for the nozzle to load the BB before firing. Now, adjusting this right can depend on many factors, but especially the type of magazine and BB weight. The default setting of 12 milliseconds is usually fine, but I'll guide you through how to adjust it anyway. You want to be at a decent shooting range when you adjust the setting, that's important, something like 50 to 80 meters. First you set the setting to 20 milliseconds. Then you fire 10 to 15 rounds, preferably in full auto, and you see how accurate it is. As long as it's good, you can keep pushing it down and test firing again and again. So you put it down from, let's say, 20 milliseconds, you test fire, 18, you test fire, 16, you test fire. And once you start seeing a change in the accuracy of feeding by following this process, you stop and then you back up again a couple of milliseconds. But even with that, if you're close to the limit and then later use a different magazine, BB, hop-up chamber or whatever, you could incur new issues. The stock setting of 12 milliseconds is just fine, and I would recommend to leave it at that unless you're troubleshooting or chasing a really high rate of fire. There is really not much maintenance to do on this engine. Generally, the best you can do is keep it clean and dry to begin with. If you do need to clean this engine, here are the main components to disassemble. The nozzle needs to be cleaned and re-lubricated on these 2 points, here and here. When you have the nozzle outside the engine, be careful of the very strong neodymium magnet set in the center here. In the rear is the solenoid valve. You would never really have to open or replace this, but if you do, it's quite straightforward. You can usually unscrew the rear part with your fingers like so. Inside is a valve stem and a little spring. Take care not to lose it. In here is a special O-ring, and that is the main seal point of the system when not firing. If this needs replacing, which is basically unheard of, please contact me to acquire an original spare part, that's important. The valve stem itself should be kept clean and given a very light coating of silicone oil lubricant, not thick grease. But I really want to stress, this engine is not a product that needs regular maintenance. If the engine is not functioning, it is most likely not related to cleaning. I've tested the engine in various gearboxes before, and in my experience, the engine and FCU will fit well in all normal M4 gearboxes, such as Specna Arms, Lancer Tactical, Delta Armory, Novritz, and most other mid-range gearboxes. It also fits well in Retro Arms, VFC, ICS, and G&G gearboxes, though the G&G G2 gearboxes need a little bit of material removed right around here, so you'll need a grinding tool for that. The Crytek gearbox also fits the Wolf engine with a little bit of material removal here, and maybe also with some compatibility issues with the MB parts going through the top here. The main requirement is fitment of the ETU and the nozzle length, which must be around normal M4 length, 21.4 millimeters. In this quick troubleshooting guide, I cover a few of the problems you can have when initially installing the engine. Some of it was already covered during previous chapters, so I would refer to those as well. If the calibration process did not run or you want to run it again, this can be done very simply. Hold down the menu button to enter the second row of options. Repeatedly press the menu button until you reach Recalib, and then you just hold the up button, and that will start the recalibration process again. If you're having issues with the selector, it could be a number of reasons. The stickers that you used on the selector plate could be loose, broken, or placed in the wrong position for your particular gearbox system. Regardless, the first thing you want to do is check the sensor details then. Navigate to the second row of options by holding down the menu button. Press the menu button until you reach option 5, Selector Throttle. Then move the selector back and forth while looking at the little arrow on the display. This should tell you if the selector positions match the FCU recorded positions. You can also move the individual cutoff points between the selector points. Do this by switching the selector around and using the up-down buttons to adjust. That should help to solve most issues of selector tolerance. Next, you can dig even further into the debug menu. Click the menu button until you reach DBG1, as seen here. The first setting, DBG1, shows the trigger sensor data. Press up to cycle through the debug menu, or down to cycle back. What you want to be on is DBG2. On this position, you can see the data from the fire selector plate's optical sensor. There's not a correct or wrong value, but what you want to look for here is that the number moves up and down linearly with the selector plate movement. For example, it should move evenly from 1500 to 3000 when moving from safe to full auto. Let's try that. And I move it slowly, and you can see the second number goes up. If the number moves flat and then up at the end, or even goes up and then down, that means there's probably an issue with the sticker on the selector plate. So it's rather complex, but this is a very good tool for troubleshooting. In the same way that the selector plate optical sensor can be configured, so can the magnetic trigger sensor. In the second row of menus, we move to Trigger Throttle. Here you can see the trigger activation point. It's typically set to 40% of the maximum travel that you registered during the calibration process. But you can also adjust the trigger point as you want with the up-down arrows. Now we need to go to 90% to fire. And now we need to go to 20% to fire. Just leave it at 40, that usually works all right. Next, you can go to the debug menu again. Here you can see what the sensor is measuring and how it reacts when you push the trigger. This can be useful because sometimes the magnet is too close or too far away, and both can give issues with detecting an even range. This relates back to the earlier chapter about how to install the trigger magnet. And when I move the trigger, the number on the left will change. It also shows the minimum registered and the maximum registered in this range. Now, if the gun is not feeding or shooting correctly, you'll have to rely on general advice for how to align a nozzle. Since you used your original gearbox and previous hop-up unit, the valve engine should fit and function just the same as it did before. However, there can always be small nozzle differences. I covered earlier how you can adjust the nozzle dwell, and I would also generally recommend against magazines with a high stack pressure. So that's it for the instructional video on how to install and set up the valve engine the first time you get it. As I mentioned before, there's going to be other videos coming out on this. There's a review video if that's not already up. Then there's going to be a video about how to use the programming unit in detail because it's got a lot more cool features. Like you can put 5 selector profiles on and different rates of fire on each selector setting and so on. It's freaking cool. So stay tuned for all of that. And this is my first attempt at a product instruction guide. I'm sure I missed some things. Let me know in the comments if you have any questions. I'd be more than happy to help. And also, I'm selling this product, so go have a look at it and let me know if you like it.